Hey guys, so this video is going to focus on how to divide two rational expressions together. So when it comes to dividing rational expressions, the main thing that maybe you want to get stuck in your head is dividing rational expressions that look like this follow the exact same rules as dividing fractions that look like this. So let's just go over what you would have to do in order to divide this example over here. So to divide these fractions, the division rule says that the first one stays the same. We change the division symbol to multiplication, and we take the reciprocal, we flip the second one. So keep, change, flip. So those exact same rules that we would use to divide this would be the exact same rules that we use to divide rational expressions. So let's go ahead and use those rules and divide here. So keep, change, flip. Keep, change, flip. All right, so in dividing this problem, I need to keep the first one. So I'm just going to drop down this first rational expression. We're going to change the division symbol to multiplication, and then we're going to flip the second one. Okay, so in using the division rule, all it does is it changes it to a multiplication problem. Now we need to multiply. But do be careful when it comes to multiplying rational expressions, you do not actually multiply them together. We're not going to take, this 40 and multiply it to everything over here and the negative 20 times the 3z minus 6. When it comes to multiplying, literally the multiplying is just a combining step. Remember, when it comes to multiplying rational expressions, it's top times top, bottom times bottom. All we're going to do is group them together all in one big problem. So we're just going to take 8z minus 16 times 40 over negative 20 times 3z minus 6. This is the multiplication step. We're not actually going to multiply together. We're going to do this. And the reason why we're going to do this is the whole point here in dividing a rational expression is hopefully what we do remember about any calculation that we do with fractions. Our last step is always to simplify. So if we're trying to simplify a rational expression, we're trying to break it down even more. We don't want to multiply it together and make it this bigger, longer rational expression. What we want to do is we want to keep it broken up because we just need to break it up even more. Because when it comes to simplifying in rational expressions, whether you're adding, subtracting, multiplying, dividing, the last step is always to simplify. And when it comes to rational expressions, simplify means factor. So we're going to have to factor this thing. So we definitely don't want to multiply it together and make it harder for us to factor because we're just going to end up breaking it apart in the end. Okay, so this is what we get after using the division rule, right? Keep, change, flip gives us this problem right here. So what we're going to have to do is we're going to have to factor this thing. So if we're going to factor this thing, so that means we're going to factor everything in the numerator and factor everything in the denominator. So I have 4 different things here, and we need to factor each one. Now, taking a look at each one of these 4 things that I have, they're all a little bit different here, which means I might use a slightly different factoring technique in order to take care of each one. So let's start with what we have here in the numerator. So here in the numerator, I have 8z minus 16. So I have this binomial here. Now, regardless what kind of factoring technique you have, the first check that you should always think of is there a greatest common factor? That should be at the top of the list regardless of what factoring technique you're using. So I need to start by looking, hey, do I have a greatest common factor here? And I do because I have an 8 in common here with this 8 and this 16. So what I'm going to do is I'm going to factor out that 8. And if you want, maybe you can pull this 8z minus 16 out to the side because I'm going to factor out the 8. So when I factor that out, remember it's the same thing as dividing it out. So if I divide this out, 8 cancels with 8, leaving me with z minus 2 there. So I really have an 8 and a z minus 2. So then I'm going to move on to the second thing I have in my numerator, which is a 40. Now, There's no special factoring technique that you can use with that. It's just a regular old number. But what I do recommend when it comes to just numbers here is break that number apart. All right, so 40 is, well, let's see, it's 20 times 2. And you can even take that 20 and break it down even more. But I'm actually going to stop there. And the reason why I'm going to stop there is because I see I have a 20 in my denominator. And what we're going to do in a little bit is we're going to cancel some things. And when it comes to canceling, we use this thought here. When it comes to certain things in math, right? If we have the same thing over the same thing, we cancel that out to a 1. So the whole reason why we're factoring this problem is because we're hoping that after factoring it, we may be able to cancel some things out. So because I see that I have that 20 there, I'm going to keep this 20 in the numerator alone because I know that, hey, it's going to end up canceling with this one down here. Okay, so I'm going to leave that alone there. Otherwise, going down to my denominator, I'm just going to keep that negative 20 as is because now I see I have the same thing in the numerator as I have in the denominator. So then I'm just going to move over to the 3z minus 6 over here. Right? So, and again, remember, we need to think about a factoring technique, starting with, is there a greatest common factor? And looking at this one here, a 3 and a 6 definitely have something in common. They actually have a 3 in common, so I'm going to take out that 3, and if I do so, I'm going to be left with a z minus 2. So I'm going to bring that in over here. I get a 3 and a z minus 2. All right, so now that we're done factoring everything, we get to cancel some things. That's my favorite part. So I see, taking a look at this problem, a z minus 2 cancels with a z minus 2. A 20 cancels with a 20. And then even then I see I have this 8, and an 8 can be broken down more. But I only have a 3 left over here, and there's no way I can break up an 8 to a 3 times something, so that's not going to help me out here. When you're done canceling, your answer is what you get when you slap everything together in the end. So in my numerator, let's see, I have an 8 times a 2, which is a 16. In my denominator, be careful here because we did not cancel the negative, we only canceled the 20. So I still have that negative there, and then I have that 3 left over. So here, my final answer is a negative 16 over 3. We factored the numerator, factored the denominator, canceled things out that we had in common, and put it all back together here in the end. But most importantly, do remember the division rule here. Keep, change, flip. You definitely have to use the division rule in the beginning first before you start your factoring and your canceling out here.